Hello gang, and welcome to equivalent trig expressions. So basically the whole idea here is that we're going to take all of the logic of working with identities and try and use it to isolate certain variables. Be very aware of the phrase express in terms of star. Basically the idea here is that when they say in terms of star, they want you to try and cut out everything else from the problem, and the only trig word that's remaining should be that star, whatever it happens to be. So if they say, given this guy, and you want to express it in terms of sign, our goal is to try and get rid of all other letters. So cotan starts off being cosine over sine. Secant is 1 over cosine. My cosines cross out, and I get 1 over sine. Gotta be honest, my gut instinct here is to switch that to cosecant so that I don't have any trig in the denominator. But they told me to leave it in terms of sine. So we're there, I'm going to stop. Alright, so here we see the same expression. They want us to express it two different ways. So regardless, I start off with turning cotan into cosecant or cosine squared over sine squared, 1 plus sine squared over cosine squared. Now I'm noticing that I kind of have a mix match here. It might have been smarter just to distribute the cotan in right off the bat, and that way the cotan and the tan would cancel. But we're here, so it's cool. If I distribute in now, I'm going to have cosine squared theta over sine squared theta plus 1. Now this could go either way, and we have to go both ways. So first off, let's try and get it in terms of sine. To get it in terms of sine, I have to get rid of cosine. Luckily, I have an identity for that. 1 minus sine squared theta over sine squared theta plus 1. I'm happy with that answer. It's got only signs and numbers in it. If I wanted to push a little bit further, I could turn the 1 into sine squared over sine squared. I'm going to realize this stuff actually crosses out. So it'll boil down to 1 minus sine squared theta. It's a little bit of a prettier answer. For cosine, I would come back to the same step, and I want to replace the sign. So I leave the cosine up top. On the bottom, I do 1 minus cosine. And I still have that plus 1. Again, I could replace the 1 with the denominator, 1 minus cosine squared over 1 minus cosine squared. And then my cosines cross out, and I get 1 over cosine squared. Oh, I'm sorry, I get 1 minus cosine squared. Pretty much the same thing. In fact, I even could have taken this final answer and just replaced the sine with the cosine, and I would have had it even quicker. Alright, so what do we got next? They tell us that cosine of x is 1/3, and we want to try and find out this. Even though they didn't say solve in terms of or express in terms of, I still wanted to get everything in cosine because that's the only number I know. Secant is 1 over cosine, so that's inviting. Tan is sine over cosine. And sine is just sine. Whenever you have a fraction in your fraction, it's a good move to multiply top and bottom by the common denominator. The common denominator here is cosine. So that's going to leave me with 1 minus sine x over sine x cosine x. I know cosine is 1/3. Right now I've got two gaping holes in my problem, and I don't know what they are. I can't express regular sine in terms of cosine. I could do sine squared, but I can't do regular sine. So I kind of have to go back to the drawing board. That's why it all goes back to chapter 1. My cosine is 1 and 3. If I do a little bit of Pythagorean theorem here, I see 1 squared plus x squared equals 3 squared. And I find out my y value is square root of 8. So my sine is square root of 8 over 3, square root of 8 over 3. And now I have numbers for everything. You can pretty that up at your leisure. Swap rules. We talked about these before. Back in chapter 2, we talked about the idea of going negative, and in the last lecture we talked about going negative. But here we have this new fangled kind of idea. This new idea says that sine of pi over 2, or 90, minus x equals cosine x. The logic for that is really simple. The idea is that if you have an angle that is x, and you have its cosine being wherever this a value is over the hypotenuse, sine of 90 minus x is that other angle of that triangle. So that other angle of that triangle, not the reference angle, so we're not talking like trig angle, but like geometry angle, this angle up here in the corner, its opposite is A and its hypotenuse is H. So the sine of this angle ends up being the exact same ratio as the cosine of that angle. And they just kind of match up. And that's true for all these shapes. So why is this important? This is important because you can set yourself up in a situation where you've got this cosine of x equals 0.05, and I might ask you for sine of 90 minus x. This is the exact same thing. If that's not readily obvious and you're not a big fan of memorization, you can always set up a reference triangle and kind of reason your way through it. It's just going to invest a little bit more time in trying to work through a reference triangle. So they tell me sine, and then they want to know cosine of pi over 6. Now, first glance, because we're in radians, this is a lot less obvious. I don't see how these connect at all. But you might remember that pi over 2, which is our interesting angle, minus the angle they gave us, could be calculated. So this is going to be 3 pi over 6 minus 2 pi over 6, which is pi over 6. So that's A. Worst case scenario, you could convert them to degrees and kind of think through it that way. So same story, as you might imagine, we can use the same trick. If this does not work when you set it up, then it's probably a clue that it's not pi, maybe, or it's not pi over 2, maybe it's just pi. What do you know? It worked again. So sine to cosine, this is a direct copy. Okay, so they gave me pi over 4. Now I can see that this is more than a half. So pi over 2 minus pi 14 is not really going to work. But pi minus pi over 14 is exactly what this is. I already forgot what the rule was on the other slide, so I'm just going to do a quick reference triangle check here. If my cosine here, pi minus that angle is over here. Cosine turns negative in this quadrant, so it's going to be the same decimal with a negative out front. 15 pi over 4 is pi plus pi over 14. So instead of that triangle, I'm going to get the triangle down in quadrant 3. Down in quadrant 3, cosine is still negative, so that's still negative 0.97. So you can see that whole logic of reference triangles really becomes huge when you're trying to figure out the signs of which quadrant you're in. Alright folks, that's all I got. Hopefully it made some sense, and you got a chance to talk to your classmates a little bit about how to do the homework. Alright, have a good one.